Good morning. Myself, Dr. S. Vidyanandani, Department of Mathematics, SRMIST Katangulutur. Now I am going to handle Unit 4 Analytic Function. Unit 4. Unit 4. Sir, 1 minute stop, sir. Work. Okay. New potuma, new they bode. Okay. Good morning, students. Myself, Dr. S. Vidyanandani, Department of Mathematics, SRMIST Katangulutur. I'm going to handle Unit 4. Unit 4 Analytic function. Analytic function. First and foremost, you must know what do you mean by complex variable. So in order to know this analytic function, complex integration is unit 5. So for everything, the basic thing you must know is complex variable z equal to x plus iy, where x and y are real. Where x and y are real. First and foremost. Secondly, you must know w is equal to f of z. W is equal to f of z, which is equal to u of x comma y plus I into v of x comma y. So is a function of complex variable. Is a function of complex variable z equal x plus iy. So one thing you have to remember before going to analytic function, remember, so this is our z plane and this is our w plane. So this is our z plane, this is our w plane. Always you will use for z plane, axis will be x and y, all the points along x axis and all the points along y axis. Regarding w plane, you will use u axis and v axis. Okay, what is the relation between z plane and w plane? This is the function which relates from domain to codomain. So in terms of what function, as w as f of z. Only in this way it relates this z plane to w plane. Okay, in mapping and conformal mapping will see in depth. Okay, next, the definition for analytic function. So definition for analytic function. So what do you mean by analytic function? I told you what is f of z. Z is not real, z is a complex variable. Now when we say this f of z is analytic function, so when we say a function is analytic function, I told you f is a mapping from z plane to w plane. So like this, if this z naught, this function should be differentiable. It should have a derivative at z naught, not only at z naught, also in the neighborhood of z naught. Whenever this condition satisfies, we say the function f of z is analytic. Again, I am repeating, when we say a function is analytic at z naught if it has a derivative at z naught and also in the neighborhood of z naught. We used to call that function f of z as analytic function. Okay, then how to identify a function is analytic? So by seeing the graph, all the time we can't say it is analytic. So certain condition should be needed. So that is necessary condition. That is what condition? Necessary condition. What is necessary condition? Which is nothing but Cauchy-Riemann equation. Cauchy-Riemann equation, which is nothing but the function should satisfy the CR equation. So what is CR equation then? This is CR equation. Ux should be equal to Vy and this condition should satisfy, and Uy equal to minus of Vx. It should satisfy the condition. Even one condition not satisfied means I can say that function is not analytic. So remember, so whenever CR equation both conditions satisfied, only then I can say the given function is analytic. Okay, right. Okay, necessary condition I told you. What about the sufficient condition? Yes, for everything necessary and sufficient conditions are available whenever we are seeking this function. Okay, so what is sufficient condition then? What is sufficient condition? Yes, I'll teach you the sufficient condition. Sufficient condition means the same thing. So the function u comma v. So u comma v should be differentiable. U comma v should be what? Differentiable. U comma v should be differentiable. And moreover, the partial derivatives, So partial derivatives. What are all the partial derivatives? Yes, come on. So ux, uy, vx, vy. Ux, uy, vx, vy. All should be continuous. All should be what? Continuous. Okay. So whenever these two conditions satisfies, uv differentiable and the partial derivatives are continuous now. So that is a sufficient condition for the function f of z to be analytic. This is the sufficient condition. Anyhow, I'll take you to the problem also. Number one, I'll test whether w is equal to z bar is analytic. Is what? Analytic. Come on. So what is w? U plus iv. What is z bar? X minus iy. Whether it is analytic? Yeah, let us check now. So what is u? X. What is v? Minus y. What is ux? 1. What is uy? 0. What is vx? Can you understand? This is dou u by dou x, which is nothing but partial derivatives. So partial derivative means obviously I used to say u is a function of two variables x and y. Partially we're differentiating with respect to x now. We have to keep y as constant. So uy is not there, so 0. Respectively, vx is 0. What is v by dou v by dou y? I mean dou v by ux by vx vy. So what is dou v by dou y? Which is going to be minus 1. So clearly the first condition, what is the first condition? So ux equal to vy. Satisfied or not? Ux is equal to no, vy is minus 1, here it is 1. So not equal. So since immediately the first condition itself is not satisfied, which implies this z bar is not analytic. This z bar is what analytic? So it's not analytic. So another problem. I'll make you to understand another problem. Show that problem is this: u equal x cube minus 3xy square plus 3x square minus 3y square is harmonic and determine harmonic conjugate and f of z. And whom? And f of z we have to find. Here I am going to introduce Milne-Thomson method, which is very important for finding f of z. So I'll give the formula directly through the problem. So first we have to concentrate on harmonic condition, right? So how to find the harmonic condition? For that I need ux. What is ux here? Dou u by, ux means dou u by dou x. So dou u by dou x, I'll get 3x square, right here, minus 3y square, and then 3y square plus 6x, right? Similarly, what is uy? What is uy here? Dou u by dou y. So dou u by dou y means I'll get minus 6xy. Later here y is available minus 6y. Okay, so here 3x square minus 3y square plus 6x, right? What is u double x? Because I have to find the condition for harmonic. So u double x, what is double x here? 6x, right? Plus 6, because y will become 0 because rate of change of ux with respect to whom? X. So 6x is available. So y will become 0, here 6. Coming to this part, u, y, y. So what is dou u by dou y? So I'll get minus 6x minus 6. So as at last, I'll get uxx plus uyy equal to 0 implies u is harmonic. Right, one part I got. Next, we have to find f of z. So what is f of z using Milne-Thomson method? So using Milne-Thomson method. So using Milne-Thomson method, what will be f of z here? So f of z will be equal to integral ux of z comma 0 dz minus I uy of xz comma 0. Right? Yes. So uy of z comma 0. What is ux available? Here it is. So ux equal to this one. So ux of, I have to substitute x as z and y as 0. So what happens here? X equal to z means I'll get 3z square minus it will become 0, right? Y is 0 plus 6z. Now, so substitute equation 1 in Roman 1. Substitute equation 1 in Roman 1. So what about uy? Uy existing, huh? So uy of x is at y0. Where is uy here? Here. So I have to substitute x equal to z. Okay, I can substitute. What is the value of y? 0. So here also y available, here also y available. So totally I'll get 0. So I can cancel this second integration. I can focus on the first integration alone. So f of z will be equal to integral. So 3z square minus 6z. So integration of this only have to integrate into whom? dz. So I'm going to get my analytic function. So using whom? Milne-Thomson method. So z cube by 3 minus 6 z squared by 2 plus c. So 3 get cancelled, 2 3 times, which is equal to z cube minus 3 z square plus c is the required, what is it? Analytic function. But still we have to find the conjugate. So still we have to find the conjugate, right? So we can find the conjugate now, right? So please recall the previous slides, only then I can focus on the conjugate. We know that ux equal to vy. We know that ux equal to vy. I'll consider vy. Like dou v by dou y, I'll write as it is. So what is ux? I got some equation. You can see the previous slides. 3x squared minus 3y squared plus 6x. Now I'm going to integrate on both. I'm going to integrate on both. So what happens here? I'll get v. So here I'll get 3 into, what is integration of x square? X cube. No, actually 3x square into integrating with respect to whom? Y. I'll get 3x square y minus 3. So y square will become y cube by 3 plus 6 into x into integrating with respect to y. Now I'll get 6y. I should not leave plus function of, because integrating with respect to y, what will be the constant in terms of x? I am getting this equation. I should not leave. Once again, I have to differentiate vx, like dou v by dou x. I mean vx, which is nothing but vx, which is equal to integrate. I mean differentiate again with respect to whom? X. So 3 into y. So differentiating with respect to x, I'll get 2x, right? So 3y into, so this 3 and this 3 get cancelled. So what I have to do here? So I am differentiating. Initially integrating, I'll get this. Now I'm going to differentiate. So 3y is available, x square will become 2x later. So here plus 6y, integrate, I mean differentiating with respect to x, now this will become 0. This one will become 6y plus f dashed of x. Okay. Now, what is vx here? Vx equal to minus of uy. Let us find the output now. Here I'll get 6xy plus 6y plus f dashed of x. Just recall the previous slides. What is vx? Minus of uy. So what is uy? 6xy. After subtracting by minus, I'll get 6xy plus 6xy. Okay. So 6xy, 6y, 6xy, 6y, I mean 6y will get cancelled. So f dashed of x equal to whom? 0. Implies, what is f of x? Obviously, it should be a constant. Substitute this f of x equal to c in the second Roman this equation. Substitute 2 in second Roman. So what we get finally, I mean the conjugate, actually this is for finding the harmonic conjugate. Harmonic conjugate. Okay, so V is equal to 3x squared y minus y cube plus 6xy plus c. So this is the required conjugate. Thank you. Thank you.